is Dr. Chillwavian. I am the lead clinician and lead researcher at the Center for Excellence in Pokémon Veterinary Medicine, and I'm delighted to be joining you today. I was invited by none other than Chillwave ASMR to conduct a Pokémon Introduction to Anatomy lecture. And what I've brought with me today is this wonderful Pokéanatomy textbook. And perhaps you have some experience with this and have looked into Pokémon anatomy in the past. In the study of Pokémon Veterinary Medicine, it is essential to have a firm grasp on the underlying anatomy and physiology of Pokémon. Today is not meant to be a comprehensive guide, but rather an introduction to the study of Pokémon anatomy. I am absolutely delighted that you've chosen to join today for this very thought-provoking lecture. Now, Chillwave did tell me that I have to say some words. Let me get my notes. Oh yes, on the 9th day of Christmas, what did Chillwave bring to you? Dr. Chillwavian and his Pokéanatomy lecture. Okay, well, I've already introduced that, so we don't have to worry so much. Chillwave did request that I wear this hat, and so I'm doing that. Times have been very busy recently, as you can imagine. The Center for Pokémon Excellence in Veterinary Medicine has become very busy, especially going into the holiday season. And as you can imagine, we are often operating very short at the Pallet Town Emergency Department. Even this morning, I was pulled from an urgent case of a Snorlax with sleep apnea, and we've had a number of Chanseys fall ill recently, and so we're actually staffed short these days. As a result of this, I must unfortunately keep today's lecture brief, but you please let Chillwave know if this is something that you'd like to see more of. Certainly, we can provide that. I think for the sake of time, we will begin, but you please pass along any questions that you may have regarding Pokemon anatomy, or any thoughts that you may have regarding the study of Pokemon anatomy and physiology. I would be delighted to read through and provide answers. I have an urgent case to attend to this afternoon of a Charmander whose fire has dimmed, and so let's be prompt. Let us begin. So, as you can imagine, our time at the Center for Pokémon Excellence in Veterinary Medicine is very, very busy, and we have a lot of different active cases that we're managing at any given time. We have an urgent care clinic where we see minor lumps and bumps, aches and pains, but also we have a complex inpatient unit where we are able to explore a number of different, more complex medical issues. In addition to this, we have a nursery where we help to facilitate the hatching of eggs and then the early life postnatal growth and development of Pokemon. So this is one of our most treasured texts on Pokemon anatomy, and you can see Pokéanatomy by Christopher Stahl. As you can see, it's laid out, categorized based on the Pokemon. This is very important because, unlike animals in our world, Pokemon do not share such easy taxonomy. We'll begin with a review of some interesting tidbits around Pokemon eggs. As you may know, Pokemon oftentimes are grown from an egg, and we can see a Psyduck egg, a Squirtle egg, a Of course, these characteristic markings are hallmark of a TOGEPI egg, but there are a number of other important considerations. For example, this is a mangy egg in this case, and the Lapras egg is a large pill-like structure. It's very unique. Electabuzz is born from this egg. There are marked characteristics that make each one very unique. For example, here, the Weedle egg. Or, this one is quite interesting, the Snorlax egg. We do see a lot of Snorlax with complex medical issues due to their significant body habitus, as well as the hallmark snoring that they produce. We spent a lot of time at the sleep clinic monitoring Snorlax. Okay, you can see here the Oddish egg, and this is the Paris egg. And this beloved egg is the Pikachu egg, which looks very similar to a Yoshi. One of my favorite eggs based on composition is this Spearow egg. It's a beautiful structure. Let us begin with Pokemon number 1. So here we have Bulbasaur. Bulbasaur are toad-like quadrupeds that house a symbiotic plant on their back from birth. Both organisms have evolved to depend totally on each other for survival. It is a mutually beneficial, or what we call symbiotic, relationship. The plant, once linked to the nervous system of its host, gains mobility and steady access to water and nutrients. The host is afforded protection by the plant's formidable array of toxic spores in muscular vines. You can see here, we have the symbiotic seed core here, and the twin muscular plant vines. The bulb opening, as you know, is at the apex of the bulb. You can see here, as we open up each layer, you can see the vascular tissue and the photosynthetic cell layer as well. Here you can see a number in the brain tissue of a Bulbasaur. It is deeply entwined with symbiotic tendrils. Those tendrils also extend into the heart and circulatory system, and across to the musculature as well. At the core of Bulbasaur symbiosis is a seed-like node. That's this piece here. Though non-sentient, this node is tied directly into the host nervous system and can process sensory data, functioning as a secondary neural ganglia, like the small secondary brains in Onyx. We'll get to that at another time. You can see that Bulbasaur also has blunted claws for digging and climbing, and stout legs to support the weight of both the Bulbasaur, but as well the bulb and plant. Bulbasaur are solitary creatures, and they rarely socialize with other species. They're territorial in the wild. There is no account of Bulbasaur surviving past infancy without its parasite, and subsequently no evidence that the tumor-like bulb can persist without a host. So these two entities are very, very much so dependent on each other. I find the health and development of Bulbasaur to be very interesting. Now you can see the further evolutionary forms of Bulbasaur. The next stage, of course, is Ivysaur, and we can see that they are distinguished only by the size and progression of their parasitic bulb. The reptilian Pokemon host remains relatively unchanged after evolution, as the plant requires the most energy for its transformation. Ivysaur's bulb flowers during evolution, growing fresh, fleshy petals in a tightly bound bud. And you can see these petals here, developing petals here. The bud orifice widens and prepares for full expansion. Dexterous prehensile vines increase in length by 25% after evolution. And we can see here is the symbiotic seed core and the branching roots that are becoming more and more integrated with the circulatory and nervous system of the Ivysaur. And you can see here there's a tuber-like center node that coordinates interactions between the two organisms. The legs of the Ivysaur increase in thickness when compared to the Bulbasaur. Bulbasaur has forward-facing binocular vision and acute external ears. You can see here also fully expanded leaves that increase the efficiency of photosynthesis. Very important for both Bulbasaur and the plant pod to gather energy. The bulb cannot complete its life cycle without a host. Because of this, it is advantageous for the symbiotic bulb to preserve Ivysaur's health. Okay. Ivysaur requires vast quantities of food to support both component organisms. To help feed their growing host, the bulb's petals give off pungent odor that attracts hungry Weedle. Yes, Weedle are a very common prey item for Ivysaur and the Bulbasaur lineage, as well as Bellsprout. Using muscular vines, Ivysaur seize small Pokemon and are even known to snatch Pidgey out of the air. In preparation for their final evolution, Ivysaur spends months conserving energy and eating voraciously in order to build up the necessary metabolic reserves. Ivysaur are also very individual Pokemon. Now, let's move on to Venusaur. Venusaur are the final stage of Bulbasaur's life cycle and represent one of the most deeply integrated symbiotic relationships in the natural world. During their evolution from Ivysaur, the seed core extends tendrils all the way into those critical body systems, piercing the brain and completely subsuming the host organism's will. This alters the Pokemon's behavior and transitions them to a more sedentary lifestyle. While Ivysaur and Bulbasaur are quite active, Ivysaur is much less active. This has much to do with its weight as well as its low center of gravity. Although the bulb and host are deeply intertwined, the two organisms cannot fully integrate at the cellular level. The bulb's plant cells produce and store energy differently than the host's. Even at this late stage of development, Venusaurs are still two mutually dependent organisms. The plant cells in the bulb must be partitioned by a series of adaptive organs and complex biochemical exchanges in order to interact with the host cells. You can see here, there is a diaphragm-like mechanism that launches seeds and spores. At the top, host tissue grows into the plant's central stalk, further integrating the two organisms. You can see a circulatory system that flows through the seed core here. These leaves are quite large, maximizing surface area for photosynthesis. And we can see tendrils extending into the Venusaur to extract nutrients from the host's digestive tract. You can see also these lumps here are actually plant tendrils that bulge through the host's outer skin. There's of course the broad padded feet and plant tendrils that complete the expansion through the host's body. You can see that here, here, and here, as well as here. Bulbasaur and Ivysaur are capable of reproduction, but Venusaur lay the most eggs during this Pokemon's lifespan. Before breeding, the seed core extends a specialized vine into the host's reproductive system, bundling each developing egg with a small symbiotic seed. Long before an egg hatches, this seed will begin integrating with the new host. This ensures that a new generation of Bulbasaur will emerge into the world, already engaged in a symbiotic exchange that has continued unbroken for millions of years. Moving on to Pokemon number 4, Charmander. Charmander is a fire-type Pokemon. They are omnivorous, reptilian pack hunters known for a jet of fire perpetually erupting from the tip of their tail. Ectothermic by nature, Charmander depends upon the heat from this flame to regulate their body temperature. It burns throughout the creature's life and is used for hunting, sexual competition, and defense against larger Pokemon. The size and intensity of a Charmander's tail flame is an indication of the individual's general health. You can see here where the flame erupts from the most distal aspect of the tail. The flame on a Charmander's tail is fed by liquid isoprene extracted during digestion from the chloroplasts of plants in Charmander's diet. Near the tip of the tail is a rough, sphincter-like orifice that controls the size of the flame. This fire is essential to Charmander's survival and is used to regulate their cold-blooded bodies as well as for defense. The ratio of brain mass to body weight for an adult Charmander indicates a higher order of cerebral activity, pattern recognition, and advanced social skills. So we can see that Charmander has a 3-chambered heart, sharp incisors, protective layers of tissue, a domed cranium containing a large complex brain, acute forward-facing eyes, thick flame-retardant skin. We can see the tail flame fed by by liquid isoprene. We can see aortic arches supplement Charmander's weak heart. And the isoprene reserve is stored here in the gut region. There's a very efficient intestinal system that extracts flammable materials from swallowed plants. It's very interesting. The center of a Charmander's life is the pack, a rigidly enforced matriarchal social structure that demands cooperation and communication. A Charmander pack can be composed of up to 60 individuals that include a number of dormant females, male and female subordinates, and various offspring. The pack hunts and forages together daily to sustain their numbers, tend to eggs, and secure territory. A large pack control hundreds of square kilometers. They are known to ignite small forests, causing other Pokemon to panic and flee from blinding smoke. This tactic gives hunting Charmander, with their large acute eyes and fireproof skin, a significant advantage. Here we can see Charmeleon. Yes. So, a horned predatory Pokemon, larger and more aggressive than Charmander. Charmeleon already bear many characteristics of their next development stage. Their long claws, increased strength, and explosive fire attacks can make them fearsome opponents. Because of their violent dispositions, they are more likely to flourish and evolve into their final form if domesticated. The humerus bone of the Charmeleon's upper arm is divided, creating a basic structure necessary for a rudimentary wing. Its skeletal density decreases by over a third, reducing their total weight significantly. During their final evolution, this process accelerates to form Charizard's hollow bones. Let's have a look. So we can see the divided humerus up here. We have developing wing musculature here as well. We can see the thick upper brow, protecting the brain during impacts. It has an adolescent crest. We have a larger masseter muscle for stronger bite. And then we see the fire size and intensity increasing with age. There's the aortic arches, as we noted, and very strong claws. Charmeleon also has arched feet adapted for hunting prey over open ground. And again, the isoprene reserve, absolutely necessary for maintaining the fire ability. After Charmander evolves into Charmeleon is driven from its former pack and forced into a life of relative solitude. This encourages genetic variation as older Pokemon in the pack tend to die off or evolve. Newly developed Charmeleon are instinctually compelled to seek out others to join their breed. This transfers the strongest genes across multiple distant Charmander packs. Once a Charmeleon has bred with members of a new pack, it is typically chased off again, though it may be permitted to join this new social group. After multiple rejections, many Charmeleon will simply remain solitary. As such, these lone Pokemon may be larger, more aggressive, and far more dangerous than that remained member of the pack. Very interesting. Very interesting. Moving on. Here we have the final evolutionary form of the Charmeleon line. This is the Charizard. The Charizard are massive reptilian fire-breathing hexapods with broad wings and bright orange coloration. Unlike their lower evolutionary forms, Charizard have long necks and two blunt horns protruding from their small heads. Charizard only evolved from lone Charmeleon and will not develop if they are part of a social group. The purpose of this restrictive process is not entirely understood, but may have been a way to ensure that only the most powerful, independent, and resilient Charmeleon reach full maturity. As a result, Charizard live in isolation and tend to avoid other Pokemon that are not prey. Their disposition towards humans is typically hostile, and Charizard are among the most difficult Pokemon to domesticate. Unlike their prior forms, Charizard naturally produce isoprene and do not derive their tail flames fuel from plant matter. They also produce hydrogen gas as a byproduct of their digestion, adding another source of flammable material to their arsenal. This gas resides in specialized chambers adjacent to their stomach to increase Charizard's buoyancy and assist with flight. Aerosolized isoprene and hydrogen gas are also the source of this Pokemon's notorious fire-breathing abilities. Charizard are capable of venting bursts of this mixture through their open mouths, igniting it with a rough, thimble-shaped organ in their sinuses. If startled or approached recklessly, Charizard will often reflexively vent flames as a warning. Let's have a look here. So we have flame retardant sinuses and a cranial ridge. You can see the horns of a Charizard have matured. You can see where the nerve core runs down here, and the mature flame expulsion. We have a broad bipedal gait, fully developed isoprene reservoir. We have flight muscles. The aortic arches are preserved. We have a membranous, highly vascular wing tissue for temperature regulation. This is housed within a supportive structure with a notable wing claw here. Due to their size and formidable abilities, Charizard have been useful human allies for thousands of years. Charizard can be ridden with a saddle for a rider's balance and positioning, and a bridle or headgear to maintain control. They were once heavily utilized in warfare, but in the modern era, Charizard have been largely replaced by mechanized alternatives. Today they are only used for reconnaissance in regions where motorized vehicles are ineffective. Moving on. Now, allow us to move forward into discussing the Squirtle lineage. Squirtle is a water-type Pokemon. They're mischievous, aquatic, shelled creatures that prefer to interact only with Pokemon within their own evolutionary line. They typically walk on two legs, but are known to sprint at higher speeds as quadrupeds. While in the water, their webbed limbs and hydrodynamic bodies propel them up to 20 meters per second. That's very fast. Squirtle is one of the only few Pokemon that possesses lungs as well as functional gills. These two sets of organs are often used interchangeably. When near water, Squirtle are known to fill their lungs to capacity with fluid and retain it. They can draw oxygen from their saturated lungs for hours and violently expel their load of water if they need to make a quick escape. Overlapping muscles on Squirtle's sides function like a diaphragm. Their motion expands and contracts its rigid shell along elastic plate-like joints, changing the volume of their chest cavity and drawing air or water into the lungs. This pressure can also be used to propel water from Squirtle's saturated lungs at high speed. Their bodies are encased in a bony shell, which hardens shortly after birth and continues to grow in thickness throughout their lives. Centuries ago, Squirtle shells were highly prized as sources of hardened ivory, with the species hunted nearly to extinction. In the modern era, Squirtle populations have recovered as synthetic materials replacing their usefulness. There's also been a significant social movement to protect Squirtles from the harvesting of their shells, and our Center for Excellence in Veterinary Pokemon Medicine is highly involved in that process. Alright, let's have a look here at the anatomical structures. So we can see the hydrodynamic gradient. We have transparent eyelids for high speed to travel underwater. We have a bony beak in place of teeth. We have efficient gills adjacent to lungs here, and those are the lungs here. We have a small intestine, strong muscles for swimming, and pelvis permanently joined to the shell. We have webbed feet and bony plates comprising the shell. You can see that Squirtle also has webbed hands. Very interesting. They're powerful swimmers and have been spotted traveling hundreds of miles from shore. Squirtle live much of their lives in water, mating while submerged and laying on their leathery eggs in sandy deposits on isolated shorelines. Only with human intervention have some Squirtles been trained to abandon the sea and live on land. However, this environment is antithetical to their migratory instincts and often leads to severe emotional problems and misbehavior. Here we have the Wartortle. Wartortle are bipedal, pale blue, aquatic reptiles easily distinguished from their lower evolutionary form by their large, plumed tails and ears. The majority of Wartortle's body is covered by its rigid shell. The shell is comprised of multiple overlapping bony plates called shoots. They are bound together by leathery protective tissue. Wartortle are not as hydrodynamic as their smaller, less evolved counterparts, but compensate in the water with their large size and more powerful limbs. From a physiological standpoint, Wartortle are well adapted to life on land and lose their gills as they grow, to be replaced with a pressurized water storage organ that allows Wartortle to eject bursts of swallowed seawater at lethal speeds. These twin compartments run the length of Wartortle's shell and are connected to their esophagus by a muscular valve. Their used for hunting and allow Wartortle to blast unwary bird Pokemon from the sky. As they evolve, those organs further develop into Blastoise's formidable dual jets. Wartortle's plume, tail, and ears appear soft from a distance but are actually composed of entirely thick, tightly woven keratin fibers. These rigid structures function as rudders while the Pokemon swims, allowing Wartortle to change directions at high speeds. This maneuverability equips them to chase down swift aquatic Pokemon, ensuring that Wartortle seldom go hungry. Let's have a look. Here we have the hydrodynamic fins. We have lungs and a water storage system, you can see here. This large pouch. We have the liver here, the spinal column here. This is the shell dorsal plate. Intestines down along the bottom here, and keratin fibers make up the tail. We have sturdy leg muscles adapted for bipedal movement, differentiated toenails, a shell chute, that is the plates that make up the anterior aspect of the shell, and we have a cartilaginous padding above the beak. Wartortle are omnivorous and eat a variety of marine and terrestrial Pokemon. They have been known to hunt Rattata and Pidgey when confined to land. They're immune to the stings of Tentacool and consume them regularly. Due to Tentacool's low nutritional value, it is likely that Wartortle enjoys their taste or derive pleasure from the hunt. This behavior is encouraged by trainers to help them keep water safe for humans. Moving on to Blastoise. Blastoise is the final evolutionary form of Squirtle and Wartortle. They're large, armored reptilian Pokemon with artificial cannons affixed to their internal water reservoirs. Ancient Blastoise populations lacked these external tubular jets, and instead had two symmetrical fleshy orifices jutting slightly from their shell. However, these Pokemon have been so selectively bred that they have gone extinct in the wild, and the only remaining populations depend upon human intervention for survival. Over centuries and centuries, human interaction and deliberate breeding, the natural water expulsion system has expanded until it became dependent upon artificial pipe-like insertions that allow focused streams of water to pass through them at high speeds. Today, these cannons contain mechanical components that interface with Blastoise's physiology to moderate stream size and strength. These components are surgically joined to Blastoise's water expulsion orifices immediately upon evolution. They seal directly into twin compartments along Blastoise's shell, which terminate in twin muscular valves. Without these cannons, Blastoise are likely to rupture or tear their own orifices, resulting in death. Let's have a look. You can see here the modern adjustable components. Pressurized water reserve here. We have the shell section over the posterior aspect of the Blastoise. Artificial cannon affixed to a reservoir orifice here. We have broad toes that support the shell's massive weight. We have a dense, thick cranium, segmented body plates, and deltoid muscles anchored to the shell's edge. Very interesting. Blastoise have been selectively bred for obedience and utility, and as such, they get along well with humans and adapt much more easily to captivity than their two less evolved forms. Blastoise are still a common sight in human cities and are often utilized in a variety of roles by police, coast guards, and military forces. Very interesting. I'd like to take a moment and speak about Pikachu. Pikachu is a small, adaptable rodent-like Pokemon notable for their electrical abilities. Pikachu are covered in bright yellow fur with brown accents on the tips of their antennae. Their tail is used for balance when standing upright and can signal the creature's mood. They are omnivorous, but with small mouths, blunt teeth, and clumsy claws, Pikachu can only eat meat opportunistically. Deceptively clumsy and top-heavy, the Pikachu is capable of rapid bursts of strength and agility when threatened, running on all fours at speeds of up to 10 meters per second. They are preyed upon by a variety of larger Pokemon species and are skittish by nature. Because of this, Pikachu are notoriously difficult to domesticate and are likely to attack and electrocute humans who attempt to train them. Pikachu's electrical abilities are well known and originate from the two thick antennae at the top of their head. Often mistaken for ears, these protrusions are actually made up of tightly wound electrocytes. Sodium ions can flow through these structures at will, causing a sudden change in electrical potential to generate powerful currents. Secondary electrolyte ganglion in Pikachu's chest can be utilized in a sequence to develop a high voltage charge. While unlikely to be lethal in adult humans, these bursts of electricity are sufficient to stun and deter most other Pokemon. Let's have a look. So here we can see the warning coloration on the Pikachu antennae. We have a primary lateral electrocyte here. We have cranial ridges here, most notable, and the sodium reservoir in this sac-like structure here. We have a secondary electrocyte here in the cheek, lungs, heart, and external oblique muscles. We have the pelvis here. We have small three-toed feet, a knee joint, and the small intestine rests here. You can see here the tail is actually quite muscular as well. In the wild, Pikachu live in tight-knit communities of up to 30 individuals with very little hierarchy, reproducing year-round. Those are the same group that tend eggs and raise children collectively and groom each other. They prefer to flee when frightened, but a serious threat can cause a group of Pikachu to rally to a deadly defense. Just 24 of these creatures working together can deliver enough electricity to kill a full-grown Onix. Let's speak on Raichu. Raichu is the mature form of Pikachu. It's a three-toed mammalian Pokemon with large hind legs and a whip-like tail. As long as their body, their tail is fully prehensile and terminates in a broad pad capable of delivering high-voltage shocks upon impact. Raichu prefer to move bipedally, unlike Pikachu, which are equally comfortable with the 2 or 4 legs. This gait allows Raichu to bound along at high speeds and leap several meters into the air to avoid predators. They're the most electrosensitive of all Pokemon, using the large webbed growths on either side of their head to detect natural electromagnetic stimuli. This finely tuned system can sense the muscle movements of other organisms, even in total darkness, and allow Raichu to orient itself to the planet's magnetic field, governed by 4 central nerves that branch from a specialized lobe in Raichu's brain. These organs terminate in the ears with the electrocytes themselves. Each one is oriented into hexagonal columns that consist of millions of gelatinous plates. Like in Pikachu, Raichu can shunt sodium ions along the electrocyte's length. Wow. This causes a rapid shift in electric potential for their potent voltage attacks. Raichu supplements this ability with additional electrocytes running along its tail. By utilizing these organs in sequence, Raichu is capable of delivering double the discharge of the less evolved form. Let's have an examination here. So we can see the electrocytes here and here, a sodium reservoir here and here. We can see ear articulation muscles. We have a secondary electrocyte here. And let's have a look here at the tail. Parallel electrocytes along the tail. Raichu is a very formidable. I hope that you've enjoyed today's lecture on Pokémon Anatomy. This is meant to be an introductory lecture and by no means comprehensive of the entire fleet of Pokémon. As you can imagine, given the number of Pokémon, it takes great time and long hours of study to become adept in this area of Pokemon anatomy and physiology. If you're interested in having a clinical experience, I do encourage you to reach out to the Center for Excellence in Pokemon Veterinary Medicine, and we have a number of different volunteer programs as well, whether it be in the egg nursery or in the Snorlax sleep lab. There's a number of different unique opportunities, and so please don't hesitate to reach out. I want to thank Chillwave for inviting me to give this lecture today, and of course, if you haven't subscribed to Chillwave ASMR, please do. We at the Center of Excellence of Pokemon Veterinary Medicine are very proud partners of the Chillwave ASMR family, and so we do encourage and support the growth of that channel as well. I want to say thank you so much for tuning in, and reach out if you have any questions regarding Pokemon Anatomy.